Okay, good morning class. So today we're looking at the grade 10 paper 2, the June exam of 2022. Okay, so let's get straight into it. So at this point we're looking at question 1. This was your analytical geometry question. We are told that in the diagram below, triangle ABC with A which is 2 and 4, B which is -6 and -2, C which is 8 and 2. P and Q are midpoints. So those are the midpoints of A, B and B, C respectively, which mean to say in that order. The question says calculate the coordinates of P and Q. So to work out the midpoint, we're going to say x1 plus x2 over 2, y1 plus y2 over 2. Okay. So it's going to be -6 plus -2 over 2 and -2 plus 4 over 2. So that's going to give you a -4 and 1. Okay? So that's -4 and 1. Because of space constraint here, it's going to take us off. And do the same for Q. Don't need to write the formula down again. So it's going to be 8 plus -6 over 2 and 2 plus -2 over 2. That gives you Q, which is 1 and 0. Okay. Let's take that out. In number 1.2 we are told, show that PQ is parallel to AC. So if lines are parallel, we know that gradients are equal. Okay? So we work out the gradient of PQ. So the gradient of PQ is going to be y2 minus y1 over x2 minus x1. So y2 is 1 minus 0 over -4 minus 1. So that gives us an answer of 1 over -5. So now we do the gradient of AC. Same story. y2 minus y1 over x2 minus x1. Okay, that simply gives us -2 over 10, which is -1 over 1. Okay, so we conclude, we say since the gradient, this normally comes at the bottom of this, no? Since the gradient of AC is equal to the gradient of PQ, which is equal to -1 over 5. Therefore, PQ is parallel to AC. Okay. Remember, if lines are parallel, gradients are equal. That's going to put here the gradient is -1 over 5. The next question. The next question says show that PQ is equal to a half AC. So here we need to work out distance formula. Okay. Distance formula is going to come into play here. So for PQ, it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So that simply gives us, for PQ, it's going to be -4 minus 1 squared plus 1 minus 0 squared. So that is 26. So AC, so it's going to be a half AC. So it's going to be a half square root. You see, this is an identity we are proving here. So we don't start off with PQ being equal to half AC. Okay? So AC, don't have to write the formula down again. It's 4 minus 2 squared. So it's going to be a half. It's going to be 10 squared is 100 plus 4. It's 104. You can take out 4 is 104. So it's going to be 104. It's going to be 4 times 26. Square root of 4 is 2. And 2 times half is 1. So the answer is root 26. Can you see that? Therefore, PQ is equal to half the length of AC, as we just proved it there to be the case. Alright. So that will be half AC. So I'm just going to write this in here again. Maybe we need it later on. Root 26. And the AC is actually 2 root 26. Okay. 1.3. Question 1.3, where I said calculate to do decimal places the perimeter of triangle ABC. So A, B, C, the perimeter. Now we already, the perimeter is going to be the sum of all the lengths. Okay. So we have the length of AC, which is 2 root 26. So we need the length of AB. Again, distance formula. So that's going to give you a negative 2 minus minus 6 squared plus 4 minus minus 2 squared. Okay? So that gives us 4 is 16 plus 6 is 36. Okay? That gives us an answer of 1452. Okay? Then we go with BC. BC, same story. It's going to be 8 minus minus 6 squared plus 2 minus minus 2 squared. Okay, so that gives us 14. Let's put it in the calculator. So it's going to give you the square root of 8 plus 6 squared plus 4 squared. So you 2 root 53. Okay, so the perimeter is going to be 2 root 53 plus 2 root 26 plus the root of 52. Remember they wanted to do decimal places. So it's answer plus 2 root 26 plus root 52. 31,97. Alright, 31,97. Alright. Now remember that 8b is root 52 and BC worked out to be 2 root 53. Okay. And the last question says, is triangle ABC equilateral, which means that all sides are equal scaling, all sides are different, or isosceles, 2 sides are equal. So I'm going with the fact that it's scaling. Why? Because all 3 sides are different lengths. Okay. Let's go to question 2. In question 2, we are told that a parallelogram SSGHS coordinates. So what I do is I draw parallelogram E, which is negative 5 and 0, F, which is negative 2 and negative 3, G, which is 3 and 5, and H, which is x and y. Okay. Determine the value of x. So if this is a parallelogram, we know that those lengths are equal. Okay. So moving from E to F, as you can see, I'm adding 3 in that direction. In other words, I must subtract 3 in this direction. So that is actually going to be 0. So we reach here, it's going to be 0. And then if I move from F to G, I'm affecting my Y. So in this direction, I'm adding 8. So I must add 8 in that direction. It's going to give me 0 plus 8 is 8. So the answer there is 0 and 8. Okay, for each. Okay. Let's carry on. In 2.2, we are told that KLM is a right angled triangle. So we've got KLM. With K, determine which KLM is a right angle. So of course the theorem of Pythagoras needs to be applied. Okay? Or, but it's going to cost us to calculate the lengths of all three sides. Otherwise I can work out the gradients. The product of the gradients is -1, then it will result in those lines being parallel and perpendicular. Sorry. Okay, so we're going to go with the gradient of LK, y2 minus y1 over x2 minus x1. So that gives us 3 over -2. The gradient of our m is going to be -9 over 2 minus 7, -half minus 1. So that gives us so it's going to be -9 over 2 plus 7, plus 1. So to give you 5 there. So definitely not those two there. So let's go with the gradient of Km. Okay. So y2 minus y1 over x2 minus x1 again. So it's going to be -9 over 2 minus 4 over minus half minus 3. 9 over 2 plus 4 over -half plus 3. -1 over 5. Okay, can you see? So those two goes together. So we say since the gradient of Lm times the gradient of Km is equal to 5 times -1 over 5, which is -1. Okay, so this is Lm and Mk. So it's actually 90 degrees there. Okay, the diagram. Sorry about this one. Okay, switching off. Okay, so in conclusion we can say therefore the angle will be at angle M is equal to 90 degrees. Okay. Sorry about this one. This computer is switching off now. Okay, in question 3 we are told that if B is equal to 37 degrees and alpha is 44 degrees, okay, I'm going to pause the video, okay, calculate the value of, so yes, it's a matter of substitution, so it's going to be sine squared B, which is 37 degrees, plus 2 cos of 44, which is your alpha angle, okay, so you put that in the calculator. So you're going to put sine squared. So what we do is we open a bracket, we put sine 37, close the bracket twice, squared. Okay, plus 2 cos 44. So that gives us 1,8. Gives us 1,8 there. The next one. The next one we have tan of alpha, so it will be tan alpha, which is 44, times cot of 37. So that's going to be tan 44 times, now 1 over tan is cot. Okay, that's where I go. I'm going to pause the video at this point. Okay, so I said that tan of alpha times cot of beta. Alpha is 44, beta is 37, so it's the tan 44 times cot 37. 1 over tan is equal to cot, so I converted the cot 37 to 1 over tan 37. From here we just put it in our calculator, so that would simply be tan 44 times 1 over tan 37. It gives you 1,28. Okay. Let's carry on in question 3.2. The question says solve for x, where x is an element of 0 to 90 degrees, which means to say that the angle is in the first quadrant. Okay. Give a reason for your, give your answer correct to 1 decimal place. So what we have to do first is, we need to isolate the trig ratio. So I divide both sides by 8. So we have cos of x plus 10 is equal to 5 over 8. Now to get the angle on its own, remember I can't take the 10 degrees over. To get the angle on its own, we're going to take r cos on both sides, so x plus 10 is equal to r cos of 5 over 8. Okay? So I put in the calculator r cos 5 over 8 gives me an angle of 51,32. Then I take the 10 over, becomes minus 10, gives you 41,32. So the x is going to be 41,3 degrees. Okay. Let's look at the next question. Cosec. Now again on the calculator we don't have cosec. Okay? But we know that cosec is the reciprocal function for sine. Not so. So that is 1 over sine 2x is equal to 2. So what I do now is I cross multiply. Again, we need to isolate the trig ratio. We need to have the trig ratio on its own first. So it's 1 is equal to 2 sine 2x. Then I divide it by 2, so it's going to be sine 2x is equal to half. Arc sine of half should be 30 degrees. And then I divide by 2, gives you an answer of 15 degrees. Okay? So arc sine or shift sine of half divided by 2 gives you 15 degrees. Okay? The 3.3, the question says, given a triangle ABC below, write the following in terms of A, B, and C. So the first question was, okay, so the first question was for tan of A. As we know that tan stands for O over A. Remember, it's sine, cos, tan. Oliver has a hat of apples. Okay, so tan is opposite. Remember, it's angle A. That is your opposite to angle A. If you're talking about angle C, that is your opposite to angle C. Okay, so tan of A is going to be opposite, which is BC, over adjacent, which is AB. Okay. Then cos of C. Cos is adjacent of our hypotenuse. Remember, now it's angle C in question. So it's adjacent, which is BC, over hypotenuse, which is AC. Then they want tan of A, sine of A over cos of A. So sine is R over S divided by A hat. Okay? So sine for angle A, that's the angle in question now, it's going to be BC over AC. Okay? BC over AC must be divided by AH, A over H, which is AB over AC, hypotenuse. That will change to multiplication. So BC over AC times AC over AB. That will cancel and leave you with BC over AB. Not so? So what do you notice about 3.3.1 and 3.3.3? The same answers. So what can we say in conclusion? The question was tan of A. Of course, tan of A is BC over AB. And sine of A over cos of A is also BC over AB. So that means to say that tan of A will always be equal to, in this case, tan of A will be equal to sine of A over cos of A. And that's an identity we'll look at sometime in the third term. We'll do some playing around with identities and so on. Yes? Yeah. So you're asking, if you had tan of B, would be the same as sine of B over cos of B. Yes, absolutely. Okay. 3.4, it says evaluate the following without using a calculator. Okay. So if you can't use a calculator, what would we be using? Special angles. So special angles as follows: that's your 30, 1, 2, root 3. 45 degrees is 1, 1, root 2. 0, 90, 90. This is not a triangle, but works for what we're looking at. Okay. So sine of 30, there's your 30 degrees, remember that's 60. Sine is opposite over hypotenuse times. There's your 60 degrees. Tan is opposite, which is root 3 over adjacent, which is 1. So we divide by tan of 30 is opposite of hypotenuse, and opposite of adjacent, so is 1 over root 3, times cos of 60. There's your 60 degrees, adjacent of hypotenuse, which is a half, minus tan 45. Tan is root 2 over root 2, or 1 over 1. Okay, that's your opposite and your adjacent. So this here would simply give us on top as root 3 over 2 must be divided by the denominator, which is 1 over 2 root 3 minus 1. So that will flip around, so it will be root 3 over 2 divided by, multiplied by 2 root 3 over 1 minus 1. So the 2's cancel. The root 3 times root 3 is 3 minus 1 will give you an answer of 2. Okay. I'm sure if you had put that in the calculator, you would have also got an answer of 2. But because the exam says explicitly without the use of a calculator, so we need to see that on the side. Okay? Those special angles, drawing on special angles. The next one, we are given cos of theta is equal to 5 over 30, and theta is less than 90. What does that mean? It means you say it is in the first quadrant. So it's in your first quadrant. Remember that is 9, that's 0, 90, 182, 73, 60. Okay. So that's your theta angle. What does cos stand for?
A over H.
So it's for A over H. Your adjacent is 5, your hypotenuse is 30. So I must apply Pythagoras to calculate my opposite side. Not so? Okay, and that will give us 13 squared is equal to 5 squared plus the opposite side squared. So it's going to be 169 minus, that is 25, is equal to your opposite side squared. So your opposite is going to be 144, which is 12. Okay. With the aid of a diagram, that's exactly what they did, and without the use of a calculator, determine the value of it. Now what does sine stand for? Opposite of hypotenuse. Not so. So my opposite to the angle is 12, my hypotenuse is 30. There we go. Okay. Sec is the inverse, so the reciprocal of? Sec is the reciprocal of? Cos. Cos is adjacent of hypotenuse, so it's hypotenuse over adjacent, plus tan is opposite over adjacent squared, plus 1. So your hypotenuse is 13, your adjacent is 5, plus your opposite, which is 12. Your adjacent is 5 squared, plus 1. From there, I can just punch that in the calculator. 13 over 5, plus 12 over 5, squared, plus 1. 2, 3, 4 over 25. Just check if that's correct.
Yes, that's
Correct. Okay. Question 4. Question 4, we are told consider triangle PQR below. Is the point on QR QPS 37 degrees, angle R is 28 degrees, PR is 17, SPR is theta, and angle PSR is beta, SPR, The question is calculate the length of PQ, which is this length. Okay, so what you should note is that PQ is in right angle triangle PQS, and is in the right angle triangle PQR. Okay, so it's in the right angle triangle. I know I can use trigonometry. Okay. However, in this triangle, I only have the angle. Not so. So that's not going to help us. Okay. However, in the big triangle, okay, I have an angle of 28 and I have the hypotenuse. So which trigonometric function uses opposite and hypotenuse? Sine. Can you see that? So I'm going to use sine. So I'm going to say sine 28 degrees equals opposite, which is PQ, over hypotenuse, which is 17. Cross multiply. So PQ is equal to 17 sine 28. Okay, let's put it in the calculator. 17 sine 28. Use 7,98. Okay, it didn't say how many decimal places, so I'm going to work with 2. 7,9. Sorry? Did you round off? They didn't specify, so you could do any, but in the initial instruction, I think they said 2 decimal places. That's why we had to work with 2 decimal places. Okay. At least like in the previous question, when you had to work out the angle, they explicitly told you 1 decimal place. Okay. So that's going to give you 7,9. So I'm going to leave that there. So let's take this off. Okay. Next question says, determine the length of QS. So QS is this length here. Can you see that? So we're going to use the angle QS. We have an angle. This is what the angle opposite, and we have the adjacent. So which trigonometric function is that? Tan. Okay. So QS. So it's going to be tan of 37 degrees equal to your opposite, which is QS, over your adjacent, which is 7,98. So that's over 1, we cross multiply. So QS is equal to 7,98, tan of 37 degrees. 7,98, tan 37. You 6,01. Okay. You all okay with that? Let me know if I'm going wrong. Huh? Following the memo. Nice. 4.1.3 SR, which is that in there. Now SR is not in a right angle triangle. Not so. However, QRP is in a right angle triangle. Can you see that? With that, I will be able to calculate QR. Once I calculate QR, I can subtract 6,01 and then we will get SR. You guys understand? Alright. Let's go with that idea. So we're going to say we have a triangle looking like this. That is P, Q, R. We've got 28 degrees here and you've got 90 degrees here and 17. So I'm going to work out QR. You all agree with that? What is that to QR? To the angle. QR is what to the angle? Adjacent. This is your hypotenuse. Which trigonometric function is adjacent and hypotenuse? So So it's cos 28 is equal to your adjacent, which is QR, over hypotenuse, which is 17. We cross multiply. So QR is equal to 17 cos 28 degrees. Put that in the calculator. 17 cos 28. It's 15,01. 15, but did we answer the question? No. So therefore, SR is equal to 15,01, which is this whole end here, minus 6,01. Give me an answer of 9. 9 meters in this case. It's all meters, no? How do I know? Because that is given in meters. Okay, yes. Yes, Pythagoras would have been another alternative method to answer that. But it has to first be working out QR and then subtracting it again. Because you can't use Pythagoras in PSR, that's not the right angle triangle. But I think you're referring to the big triangle, no? Yeah. No, that's absolutely correct. You see, that's the nice part about maths. There's many ways of getting the same answer. That's why maths is so easy, not so. Yes. Now I feel better. Yes. Okay, so there's no other, yeah, only 2 questions here. The question says determine the size of theta. Determine the size of theta. Now is theta in a right angle triangle then? No. Okay. So we can work out this whole angle here. Yes. Not so? And then once we got the whole angle P, which is QPR, we subtract 37 degrees, you will get theta on its own. Not so? So let's go 4.1.4. So we have a triangle looking like this. I'm just redrawing, you don't have to do this. I'm just doing it so that you can see what's happening. So that's PQR. That is 28 degrees, and this angle QPR is what? 37 degrees plus theta. Not so? So what can I say? 37 degrees plus theta plus 28 degrees plus 90 equals 180. Why? Sum of triangles. So interior angles of a triangle. So theta is equal to 180 minus 37 minus 90 minus 28. Would you? 25 degrees. Okay. Or you could have worked out angle P first and then subtract 37 afterwards. Okay. Then they want, so that's going to be 25. (4.1.5) to calculate angle beta. So you see angle beta lies here. So that is the exterior angle of triangle. Not so. Exterior angle is equal to the sum of the 2 interior opposite angles. Okay. So 4.1.5. So angle beta is equal to 37 plus 90 degrees. The reason is exterior angle of triangle, and it's triangle PQS. So that's going to give you 127 degrees. Any confusion there, people? Huh? No? Okay. We're told that the cell phone tower CE, okay, cell phone tower CE is positioned next to a building AB. Then we are told that building AB, the angle of depression is the angle that goes down from the top of the building to B to the foot of the tower is 62 degrees, as is marked there. And the angle of elevation, which is the angle that's going up from B, is to the tower E, is 34 degrees. The distance between the foot and the building is 200. The foot of the building and the tower is 200. So I think I've cut it off there. It should have been reading 200. Okay. Is that correct? Yes. Okay, my mistake. Right. So everything they spoke about, of course, is on the diagram. Okay. So let's do this. The question says determine the height of the tower EC. The height of the tower EC. So in other words, I'm going to calculate this whole length. Not so. But now that is not in a right angle triangle. Not so. However, we can work out. Remember, this is 200, so that from there to there is also 200. Not so. So what can I calculate first? We calculate DE and then DC. Why? Because those are in right angle triangles. And then we can add it together and then we'll get the low length of C. You guys understand? So I'm just going to draw here in triangle BDE. Again, you don't have to do this. It's just like a guide. Okay. I think I had to make it compulsory for you to do it. Maybe you got this question right. No? So which trigonometric function uses opposite and adjacent? Tan. So you say tan of 34 degrees equals opposite, which is ED, over adjacent, which is 200. Cross multiply. So ED is equal to 200, tan 34 degrees. Okay, you can work that out if you like. Okay? Okay, work it out. Let's see what you get. So you got 200, tan 34. It's 134, 91. 134, 9. Okay? Then, in triangle BDC, the triangle looks like that. Is your 90, of course that's your 200. BDC, we want to calculate, that is 62. We want to calculate the opposite. So what do we have? We have the adjacent. So which trigonometric function is opposite and adjacent? Again, tan. So tan of 62 degrees equals opposite, which is DC over 200. So DC is equal to 200, tan 62 degrees. 200 tan 62 gives us 376, 376, comma, 15. But they ever answered the question? No. The question was to calculate the length of EC. So that would simply be 134,91 plus 376,15. This plus 134,91. It gives you 511,06. 511,06 meters. Okay. Any confusion there? Okay, and the solid 6 marks there. Right, now we're going on to our favorite, geometry. No? Here we are told that complete the following statements by writing down the missing word, phrase, values. Okay. So in 5.1.1, the what angles between parallel lines are supplementary. What does supplementary mean? Adds up to 180. So which angles add up to 180 between parallel lines? Co-interior. Not so. Next, the midpoint theorem states that a line is drawn from the midpoint of one side to the midpoint of the other side. So this is basically what you should see in your mind. ABC, the midpoint, the one side drawn to the midpoint of the other side. Then it is parallel to the third, and the length is half the length of the third side. Okay, nice. The diagonals of a kite. So what do is I draw a kite. Diagonals of a kite. That's your diagonals there. So what do we know about the diagonals? It bisect one diagonal bisect the other, and it's perpendicular, and the diagonal bisect its vertex angles. There's all the theorems dealing with it, with the diagonals of a kite. So the diagonals of a kite, A and A, meet at 90 degrees. Huh? The diagonals of a kite, A square. Wait. The diagonals of a kite, A and A, meet at 90. The diagonals of a kite, A square. Oh, A square. My word. And A rhombus. Sorry, man. Not so fast like you guys. Meet at 90. Nice. One day going to be just like you, no? Just not today. Right. People, 5.1.4. The reason, it's one of those, okay. The reason that triangle ABC is congruent to triangle ABC is congruent to triangle DBC. Given alongside is side angles. Side angle. That's a case of congruency. No? The reason that I would never state it like that, but okay. You guys are almost the English people, no? I would have gotten that some probably wrong. And that's why they teach you English as well. Huh? They can read your maths paper. No? Don't be fooled otherwise. Okay. We are told that KLMN is a parallelogram. Right, it's a parallelogram. There are 4 properties of a parallelogram. What are the 4 properties? 2 pairs of opposite sides are parallel. 2 pairs of opposite angles are equal. 2 pairs of opposite sides are equal. Diagonals bisect each other. So if you look at this here, definitely opposite angles are equal. Not so much. Right, so we are told that. Determine the value of x. So what do we say? 5x plus 18 plus, is equal to 7x minus 30. I must write neater, no? We got visitors today. 5x plus 18 is equal to 7x minus 30. Why? 2 pairs of opposite angles equal in parallelogram. Right. So for x, so it's negative 2x is equal to negative 48. Divided by negative 2 both sides, x is 24 degrees. Okay. Okay, let's do the next one. 5.3. In 5.3, in the diagram below, ABCD is a parallelogram. So many things come to mind. Such that AB is equal to, AD is equal to BE. Angle A is 124 degrees. There's 124 there. BE bisect. BE bisect BEF. BEF. ED, sorry, I'm reading wrong. ED bisect. So that angle is equal to that angle. No? ED bisect BEF. And BEFD is a quadrilateral. Calculate the values of x and y. nice, no? Of course not. Right. People, this is a parallelogram which makes this length equal to that length. And that length is equal to that length. Not so? Which makes, yes, Michael?
And it's angle A equals angle C.
Nice! Okay. So, you see where your x lies. So I need to work out this. Those angles are the same. But I can calculate this. I know that's 124. Not so? Right, so let's do our thing. So we're going to first start off by saying that DCB is equal to 124. Why is that 124? Two pairs of opposite angles equal in parallelogram. You all okay with that? So now I can calculate this angle here by working out angles on a straight line. So now I say that BCE is equal to 180 minus 124. It's angles on a straight line. Okay, that gives you 60 is 56 degrees. Not so? That is 56 here. But now, you see this length there, that marking wasn't there on the diagram. So I must introduce it before I'm going to use it. Not so I must state it. So we know that AD is equal to BC. Why? Not an isosceles. Why is this length equal to that length? Yes, two pairs of opposite sides equal in. But now we know that BC is equal to BE, which is equal to AD. Now AD and that was given equal here. Not so? That was given. So now we can conclude that. Okay. Which now means to say that this angle here, which is BED, this angle here, is going to be 56. So BEC is equal to 56 degrees. Why? Angles opposite equal sides. Have I solved for x? Not yet. So I'm going to solve for x now. Interior angles of the triangle. So x plus 56 plus equals 180y. Sum of triangles in this triangle, a BCE. Okay. So x works out to be 68 degrees. Okay. Now we're going to solve for y. We can work out sum of triangles here, not so? However, that angle is short. We need that angle. But we know that DEF, that angle is equal to what? 56 degrees. Why? Because ED bisect BEF. That was given to us. Not so? It is 56 degrees. So now what do we say? Y is equal to 180 minus 90 minus 56. Why? Sum of triangles in this triangle. DEF. Okay. 90, so it's going to give you 34. Okay. This was a nice one, no? I like it. They must challenge us, otherwise we're going to tell everybody we do maths, but we don't do maths. You must do it. Okay. They must challenge us somehow or other. So here we are told in question 6 in the diagram below, triangle ABC, which is a big triangle, is similar to triangle DEF. Nice. No? The question says prove that. No. If it's further given that AP, up here, yeah, is equal to DE, and AQ is equal to DF, you are required to prove that triangle APQ is similar to triangle DEF. But we are told that triangle ABC is similar to triangle A. So we are told this is the case, that is similar to this triangle. Okay, we are told that. But they want us to prove that triangle APQ is similar to triangle DEF. Okay. So let's prove this one is similar to that. So how do we start off? We say in triangle APQ and triangle DEF. What can we say? The angle D is equal to angle A. Angle D is equal to angle A. Why? It was given equal. I can prove congruency here.
In the memory, you said AB over DE AC over DE.
So they're using the fact that they're using corresponding sides. Okay? So let's just hang on with this. So they said that AB over, it's coming from here now. AB over DE is equal to BC over EF, which is AC over DF. Why? Because the sides in proportion. Okay? So AB, this one will be triangle, but we know that DE is equal to AP. No? It was given. Then AQ, no, the DF, which is this one here, is equal to AQ. That was given. Okay. So therefore, AB over AP, so AB over AP is equal to AC over AQ.
You said this from Mr. T.
Thank you. Okay. So AC over AQ. So in conclusion, we have to say therefore triangle APQ is similar to this one be since. Okay, since triangle APQ is similar to triangle DEF. Why? Because sides in proportion. Okay. Is that what the memo says? Yeah. You see, when two triangles are equiangular, then the sides are in proportion. Okay? Then when the sides are in proportion, as I just showed you now, then the triangles are equiangular, which means to say they are similar. Okay, those are the two rules for similarity. Okay, that wouldn't have solved us the problem. Okay, so that is actually the wrong approach. That would have gotten you no mark out of 3 for that one. Okay. 6.1.2. Whoops. Okay, they have another question here. The question says, just take it out here. So 1.2 hence or otherwise prove that PQ is parallel to BC. Now remember we proved that these triangles are similar. Not so? So which means to say that angle there, APQ, this angle there has to be equal to angle B, which is equal to 1. Why is that the case? Not because of the corresponding sides, that is the case. Remember, we must prove that it's parallel. Corresponding is based on the fact that it's parallel. So, that is the case because the triangle APQ is similar to triangle DEF. Why? Because the corresponding angles are equal. Not so. The corresponding angles are equal, which means to say that angle A is equal to angle D. Angle P is equal to angle E. APQ and DEF. APQ, so DEF. ABC. ABC and DEF. APQ. APQ and DEF. ABC. So the big one and this one. APQ. And that. So I see that APQ is similar to triangle DEF. DEF. Okay, so I'm supposed to bring angle E in here as well. It's not enough for me not to link E to it as well. E which is equal to angle B, which is equal to 1. So all of this is 1. Okay, if I'm using this reason here, then I have to bring in this angle E here. Okay. Now, what do you notice now? That those angles are equal. Can you see that? So we say since angle APQ is equal to angle B, which is equal to 1. Okay, I'm repeating this here for some reason. Therefore, PQ is parallel to BC. Why is PQ parallel to BC? Now that corresponding rule comes in. Corresponding angles are equal. You have to end up with saying that the corresponding angles are equal. Okay, the next question. It is further given. The diagram is messed up already. Okay. It is further given that AP 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 is 3.5, PB is 4, AC is 8. Determine the length of DF. DF. Now DF is the same as AQ. Not so. So I'm going to go with AQ first. Now from the previous ratios we know that AP over AB is equal to AQ over AC. Why? Because triangle APQ is similar to triangle ABC. That is coming from that fact. No? So AP is 3.5. AB though is 7.5 equals AQ, which is what we want to calculate, over AC, which is 8. Okay. From here we cross multiply, so AQ times 7.5 is equal to 8 times 3.5. Okay? Divided by 7.5 both sides. So AQ, work that out. Going to give you 8 times 3.5 divided by 7.5 gives us 3,7. Is that correct? Or 3 and 11 over 15. Okay. Since that is in centimeters, this will be in centimeters as well. Okay. Let's see what else is here. 6.2. 6.2.1. So I'll do this I'll complete this in this video now. I know your next teacher is probably waiting for you guys. Alright? If you're interested, you can watch the video later on. The last question, okay? And the bonus question also. Good morning, class. Okay, as promised, I'm going to go complete this quickly. So in 6.2, we are told that in the diagram below, D is the midpoint. So D is the midpoint of AB, and D is parallel to BC. Question says, give a reason why angle E is the midpoint of AC. I'm going to say why E is the midpoint of AC. D is the midpoint because of the midpoint theorem. It's actually the converse of the midpoint theorem. Okay, because if you say midpoint theorem, that means you say that the midpoint is connected of one side to the midpoint of the other. In that case, it would be the midpoint theorem. However, since we use a parallel line and a midpoint, so it has to be the converse of the midpoint theorem. In 6.2.2, we are told that it's further given that f is the midpoint of AG. Okay? Then we are told that ADEF is a parallelogram. ADEF, that's a parallelogram. Okay? And that BD is the root of 32. BD is the root of 32. Determine the length of CG. CG. Is that you? Who is it? Is there something wrong with you? Okay, so CG is this length here. Okay. So we know that CG is double the length of FE. Okay? Because here it's also the midpoint theorem is evident. Okay? Then we know that FE is equal to AD. And AD would be equal to DB. Okay? So let's lay that out. Write it out. So firstly we know that AD is equal to root 32. Why? Because D is the midpoint of AB. Okay, then FE is equal to root 32. Why? Because two pairs of opposite sides equal in parallelogram. Okay? Then, since AF is equal to FG, that is given, and AE is equal to EC, that's also given. So therefore, so here the midpoints is connected, okay? So therefore, FE is equal to a half GC. They wanted you to work out GC, so GC is going to be double FE. Why? Because of the midpoint theorem. Okay? So FE, we know is going to be root 32, so it's 2 times root 32. Okay, if you put it in the calculator, you should have 2 root 32. It's going to give you 8 root 2. Okay? But that is sufficing. Get the mark, put it in both ways. Okay? And the bonus question, we are told that quadrilateral ABC, D is drawn with AB produced to E, BC, but now produced means extended. BC produced to F, and CD produced to G. Then we are told that ADG is 127, GCF is 64 degrees, and EBC is 79 degrees. Determine the size of ABD. DAB, so this angle. So of course this angle here can be worked out. So ADC is equal to 180 minus 127. Okay, that's the angles of the straight line. So that is 180 minus 127 gives us 53 degrees. That is 53 degrees there. Then we can say that GCB is equal to 180 minus 64 degrees, this angle here. Again, angles on the straight line. So that is going to give you 116 degrees. Then we have this angle here, which is ABC. It's 180 minus 79. 79 gives you 101 degrees against straight line. Now it's 101. So now we know that angles on the in a quad adds up to 360. Okay, so 53 plus 116 plus 101 plus DAB equals 360. Why? Because that's interior angles of a quad. So DAB is equal to 360 minus 53 minus 116